Okay, so I got a couple of billiards balls. One comes in, hits the other. The first one's not moving. Second one, I'm sorry, B is not moving. A comes in at the velocity shown. Okay, and basically I want to find the velocity right after impact. Okay, I know the coefficient of restitution, velocity, masses, all that good stuff. So first thing I want to recognize is that my line of impact is essentially my x direction. Okay? And again, along the line of impact, two things are true. The conservation of momentum for the entire system is true. Okay? So we'll start with that one. So initially, along the line of impact, that's the x direction essentially. The only thing I've got is velocity a coming in initially, right? And that's got a mass of 0.2. I've got the negative sign because it's traveling in the negative x direction. And that is 10 cosine 30 in the x direction. So that's the initial momentum of this thing. Okay. After the collision, I've got two velocities, right? So 0.2 times VA2x plus 0.2 VB2x. Okay, so that is conservation of momentum for the entire system because, again, that impulse is going to be internal to the system. Okay. Now, the other thing I've got is the coefficient of restitution. So I could take that 0.8, and it's going to be the difference in the final velocities, which will be VB2x minus VA2x divided by the difference in the initial velocities, which is going to be that first one, again, is going to be negative 10 cosine 30. Okay? And there'll be minus 0 because there is no velocity of B initially. Okay? So two equations, two unknowns, and I can find that VA2x, when I do the algebra to do this, is negative 0.866 meters per second. Okay? And VB2x is going to be equal to negative 7.79 meters per second. Okay? So that gives me the velocities along the line of action after the impact. Now, perpendicular to the line of action, I remember that my velocity remains constant because there is no impulse perpendicular to the impulse, right? So that means VA1 in the y direction equals VA2 in the y direction, which equals 10 times the sine of 30, which equals 5 meters per second. Similarly, VB1 in the y direction equals VB2 in the y direction, which is 0. This thing is not moving initially in the y direction, so it's not moving in the y direction afterwards. Therefore, the velocity of B2 is all in the negative I direction, negative 7.79 meters per second, whereas VA after impact is going to be negative 0.866 I plus 5j meters per second. That is what the velocity of A looks like after impact. So it continues in the y direction, the speed it was going, okay, and it just bounces back just a little bit in the x direction, right? It was coming in with a pretty good click, bounces back in the opposite direction, but just a little bit, right? But the vertical y perpendicular to that line of impact does not change after the impact.